In this question, we're given that xy is equals to 3x squared plus y squared. We're asked to find dy dx. Okay, so as we observe this equation, we can see that it is an implicit equation. So y is not just expressed in terms of x, but we have y terms on the left hand side and also on the right hand side of the equation. So in this case, we will need to make use of the implicit differentiation. So let's begin by differentiating both sides of the equation with respect to x. So let's differentiate xy with respect to x. That will be equal to the differentiation of 3x squared plus y squared with respect to x. In this first part, we can see that it's the product of two functions, x and y. In this case, we will need to make use of the product rule. So in the product rule, let's recap. So when we have a differentiation of two functions, u and v, for example, we will put down the second function v and then differentiate the first function u with respect to x plus putting down the first function u and multiplying by the differentiation of the second function with respect to x. Coming back here, we can make use of the product rule, and the second function here is y, so we put it down and we multiply by the differentiation of the first function x with respect to x, and then we plus, okay, putting down the first function x and multiplying the second function y with respect to x, and that is equals to the second part of the equation on the right hand side. We can see that this is a sum of two functions. We can make use of the sum and difference rule and differentiate the two functions term by term. And here in the first part, we can see that there's a constant multiple 3. By the constant multiple rule, we can actually take it out and put it in front. So it's the same as 3 multiplied by the differentiation of x squared with respect to x plus the differentiation of y squared with respect to x. So when we differentiate x with respect to x, we get 1. When we differentiate y with respect to x, we can put down as dy dx. In this case, put down the 3. Here, making use of product rule, we can bring down the power 2, reduce the power by 1. So we get a 2x here. For the second term, since we are differentiating y function with respect to x, we will differentiate the y square with respect to y first. That will give us a 2, bring down the power 2, y, reduce the power by 1, so we get a power 1 here. And then we will need to multiply by an additional term, dy dx. So we are applying the implicit differentiation as well as the chain rule here. So since we want to find dy dx, we will need to bring the terms with dy dx on one side. So the dy dx terms will be this one and this one. So bringing it over, okay, so this part will keep the same. This we will bring over from plus to minus. Here we will simplify, becomes 6x. Y, bring it over, becomes minus y. Take out the common factor, dy dx. Here we're left with x minus 2y. And here we're left with 6x minus y. So make dy dx as the subject. Okay, we can get 6x minus y. So this extra factor here, we can actually bring it to the right hand side. So multiplication becomes division. We will divide this by x minus 2y. And that will be our answer for dy dx.